Hey Amanda, these are Ixl's R8 and R10. So let's start with R8. For R8, you have to find the length of the missing side using trigonometry. Now we know to use trigonometry when the angles that we have are not one of the special right triangles, so not 30, 60, 90 or the 45, 45, 90. And so we are missing a side and then we only have one other side. If you have two sides, you can use the Pythagorean theorem, but that's why we use trigonometry here, because we're only given one side and we're looking for another. So in this one, it's asking for VW, which is this side here. So the first thing that you're going to do is you're going to identify your angle, which is the 24, and then you're going to label the two sides that you're given and the one that you're trying to find. So this one, I'm going to call it X. This is what I'm trying to find. The side that is across from the angle, this is the opposite side. The 5 is the hypotenuse because it's the diagonal line, or you can identify it because it's directly across from the 90. So now we have to determine what trig function we're going to use. Since we have the opposite and the hypotenuse, I have here SOHCAHTOA, we look for OH, which is here. And this is using sine. So we would write out the equation, sine of the angle, which is the 24, is equal to the opposite over the hypotenuse. So now what I do is I solve for x. Whatever is in the denominator, that's what I multiply. So I'm going to multiply 5 to both sides. So x is equal to 5 times the sine of 24. In order to figure out this number, you need the calculator. So this is my scientific calculator. You look for the sine button. Well, sorry, let me back up. We have 5 times the sine, and then it opens a parentheses so you can put the angle, 24. And we get 2.03. Now it says here to round to the nearest tenth, which is the first decimal point. So this would just be 2.0 or 2. For the next one here, we're trying to solve for RS. So again, I'm going to call this X. Now let's see what sides we're given here. This is the angle. The 5 is directly across from the angle, so this is the opposite. This long diagonal here, that's the hypotenuse, but I don't need to use that because I need to use this one here where the X is, and that's the adjacent side. So now I look for the trig function that uses the opposite and the adjacent. So this is cosine for adjacent over hypotenuse, and this is tangent for opposite over adjacent, which is what I have. So now I'm going to use tangent. So we would write the tangent of 68 is equal to the opposite, which is 5, over the adjacent, which is x. So the order here of the letters tells you how to write this out. So sine opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So continuing here, I need to solve for x, but x is in the denominator. Whatever is in the denominator, that's what we're going to multiply to the other side. So we have x tangent of 68 is equal to 5. Now the tangent of 68 here, this is just another number, because when you put this into the calculator, you get a decimal. To solve for x, this means x times the tangent. So I need to remove this tangent of 68. And since this is multiplied, I would divide by the tangent of 68 to both sides. So this means that x is equal to 5 over the tangent of 68. So now we go to the calculator. 5 divided by tangent of 68, and we get 2.02, which is rounded to the nearest tenth, would just be 2. Let's try a couple more, and then we'll move on to R10. Here we want to find the length of XZ. which is this side here. So I'm going to call this x. Now here's my angle. The x is the opposite. The 4 would be the adjacent. Since the adjacent is always the side that is next to the angle, like that's one of the sides of the angle, but not the hypotenuse. The hypotenuse is always that longest side directly across from the 90. So we have opposite and adjacent. That means that I would have to use tangent. So tangent of 51 is going to equal to the opposite, which is x, over the adjacent, which is 4. So now to solve for x, we're going to multiply 4 to both sides. And we get that x is equal to 4 times the tangent of 51. So now we go to the calculator. We put 4 times tangent of 51, and we get 4.93, which again, rounded to the nearest tenth, would be 4.9. Last one here for R8. We have here my angle 63. I need to solve for RT. RT is this side here, so I'm going to call this x. Now the 8, that's across from the 63, this is the opposite. The x is across from the 90, so this is the hypotenuse. So opposite hypotenuse, that means that we would have to use sine. So the sine of 63 is equal to the opposite, which is 8, over the hypotenuse, which is x. So now to solve, whatever is in the denominator, that's what I multiply to the other side. We get x sine of 63 is equal to 8. But remember, we want to get that x alone, so we're going to divide by the sine of 63. So x is going to equal to 8 over the sine of 63. So now we put this into the calculator. 8 divided by sine of 63, and we get 8.97. Now when we're rounding to the nearest tenth, this 7 would round the 9 up, which would then turn this 8.97 into 9. Now all of these, we've only used sine and tangent, but it's the same principle when you have cosine. But cosine would use the adjacent and the hypotenuse. So if that's the case, and it's the same process. As you see, all of these we solve in the same way. It's just when you put in the calculator, you would press the cosine button instead of sine or tangent. Now let's go to R10. R10 is to solve for a right triangle. Solving for a right triangle just means that you're trying to solve for all of the missing sides and all of the missing angles. Now for all of these are all special right triangles. So what I did here is that I have the rules for both types of triangles here, so we can use that as a reference. So your goal for all of these is to first figure out what is L, because as long as you know what L is, then we can plug it in for each side to figure them out. So let's look at this first one here. We have that this angle T is 45. If this one is 45, this one is also 45, because that's the 45, 45, 90 triangle. So I can already fill this part out. In a right triangle, the two other angles always have to add up to 90. So 45 plus 45 is 90. Now we're going to look at what we have, and we're going to label it with the correct rule. This is the 45, 45, 90, so these are the rules I need to follow. This square root of 66, this is the hypotenuse. So I look for the rule for the hypotenuse in this triangle, which is the L square root of 2. So what I do is that I make that side, square root of 66, is going to equal to L times the square root of 2. And I use this equation to solve for L. So in order to get the L alone, I have to divide by the square root of 2. When you are dividing two radicals, what you can do is divide the radicals together. Like the 66 divided by 2 is 33, but we keep it inside the radical. So L is equal to the square root of 33. Now to figure out RS and ST, I'm going to write the rules for each of these missing sides according to my rules here. Both of these, because this is a 45, 45, 90, are equal to L, which is what I solved for here. So that means that RS is the square root of 33, and ST is also the square root of 33. Now this next one, look at the angle that we're given here. This is 60. That means that this angle here has to be 30, since both of these have to add up to 90. So the measure of angle V is 30. Now to figure out the rest. Again, now we're using this one here. We have the 18 square root of 2. This is the hypotenuse. And the rule for the hypotenuse of a 30, 60, 90 triangle is that it is equal to 2L. So I'm going to use that equation to solve for L. So I'm going to divide the 2 to both sides. And I get that L is equal to 9 square root of 2. Now how do we get this number? When you're dividing something like this, where you have number outside of the radical, number inside of the radical, you can only divide or multiply, whatever the case may be, radical with radical and outside number with outside number. Since this 2 is not inside of a radical, that means that I would divide it, or divide the 18, which is also not outside the radical, by the 2. And then we just leave the radical 2 alone. So this is what I get for L. Now to solve for VW and WX, I'm going to write out the rules for both of those sides. The side that is across from the 60, this is 60, the rule is L square root 3. The side that is across from the 30 is just L. Or you can think about it like the short side is L and the long side is L square root 3. So VW is going to equal to L, which is 9 square root 2, times the square root of 3. I can only multiply the radicals together, since remember, you can't mix inside with, it has to be inside with inside, outside with outside. So 9 is my only outside number, and then square root of 2 times the square root of 3 is the square root of 6. So that's VW, 9 square root of 6. Now I need WX. The rule for WX is just L, which I solved for here. So WX would equal to 9 square root of 2. Let's do a couple more just to make sure. So I'm going to send you, or I mean, you probably already saw it, but I sent you the notes for this here. So that way, if you wanted to print this out and practice on your own and have the rules handy while you work on your Ixl, I think that would be great. Okay. For this one here, I have a 45, 45, 90 triangle. Since this angle is 45, that means angle Y is also going to be 45. Now let's write out our rules. The rule for both sides, like the both legs of a 45, 45, 90 is L. And the rule for the hypotenuse is L times the square root of 2. So what I have here is that L is equal to 48. That means that YZ is also equal to L, so YZ is 48. XY is equal to L square root of 2, so that means that XY would be the 48 times the square root of 2. Last one, we have here that 60 degrees, so that means that angle D must be 30 degrees. Now let's write out our rules. The short side of a 30, 60, 90 is equal to L. The long side is equal to L square root of 3. And the hypotenuse here is equal to 2 times L. Since I know what L is equal to, I just plug it in for each side. So CD, which is equal to 2L, is going to be 2 times L, which is square root of 41. There's nothing I can really do with that, so that would be, sorry, which one was I doing? CD. So 2 square root of 41. Now to get BD. BD is equal to L times the square root of 3. So I put this together. L is square root of 41 times the square root of 3, which when I multiply these together, 41 times 3 is 123. Now they want all radicals simplified, but 123 cannot be simplified, since the two numbers that would multiply to give me 123 are 41 and 3, which cannot be broken down anymore. So we would leave it as the square root of 123. Now just to review, let's say you ended up with a radical that was the square root of 45. If I needed to simplify this, remember that you break it down by finding two numbers that multiply to give you 45. Two numbers that multiply to give you 45 are 9 and 5. You need pairs in order to move it outside of the radical. These are not pairs. But 9 can be broken down further to 3 and 3. So here's a pair. The 5 cannot be broken down anymore. So this 5 will have to stay inside. So this radical can be rewritten as 3 square root of 5. And that would be my final answer. Okay, and those are your two IXLs.